Hey everyone, it's Miss Cole again, and we are back for our next lesson. This is our 7th lesson, and it will be on scale. Scale is pretty useful. We use it in scale drawings and models. We use scale drawings and models to represent something that is either too large or too small to work with. So here are some examples where you might see a scale model. We have architectural drawings. So we have scale models, usually more detailed than this, blueprints, to help us build and create buildings. We obviously wouldn't be able to build it and explain it as we go, so we make a small drawing that the architect and workers can work off of to build a building. Well, model trains, they're just fun, but they are scale models. And here's something very, very small. So if we have a microscopic image of, I believe, a red blood cell and a virus here, these are way too small for us to see and work with at the regular level, so we enlarge them where we can see them. So the first thing you need to know how to work with when you talk about scale drawings and models is the scale factor. This is the ratio of a given measurement on a scale model to its measurement in reality. It always does this. It always goes model to real. So, for example, we have this airplane, and here's a picture of it for real. But if we build a scale model of it, it would be a 1 to 100 ratio. So, if the length of the model is 194 millimeters, I can set up a proportion, the ratio here, my scale factor, to the model and then what we don't know. In reality, I know that it is actually 19,400 millimeters long, or 19 4/10 meters. Another example would be if you look at a map. See a map of Wisconsin, and it has the scale up here. Now I've taken a ruler and I measured that from 0 to 40 miles, it's about 2 inches, at least on my screen. And if I wanted, I could use that then to find the distance from Eau Claire to Madison. Let me go back to my presentation. Okay, so my scale factor then is 2 inches to 40 miles. I can set it up over here as a ratio, and it equals 7.5 inches, which is about the distance on my map from Eau Claire to Madison, over some miles that I don't know, cross multiply and divide, and I get x equals 150 miles. So, if you're going to use a scale factor, you first have to know how to find a scale factor. We have our measurements from reality. So if I have a model and it's 2 inches, and then I measure in reality how long it is and it's 5 feet, I need to first convert these to the same units. So I say 5 feet equals 5 feet times 12 inches per foot, and I get 60 inches. So now I set up a ratio of the model to the actual. So I have 2 to 60. And then you simplify. Remember that your ratios always need to be simplified. So my scale factor in this case, if a model was 2 inches and it was 5 feet in reality, the scale factor would be 1 to 30. Let's do some examples of finding scale factors. Now remember to pause the video so that you can try this on your own. That way you'll know if you really get it or if you need to rewind and get a little bit of help. So if I have a red blood cell, just 6 micrometers wide, which is 0.000006 meters, or 0.006 millimeters, in a picture it is actually 2 centimeters across. Let's find the scale factor together. Now remember, you have to first convert these to the same units. So if I put them both in meters, well, this one is already converted to meters for you up here, but 2 centimeters is really 2/100ths of a meter, so I set my scale 0.02 to 0.000006, and now simplify. And you get 20,000 to 6, but that's not simplified all the way, 10,000 to 3. So here we have an idea where we're blowing something up. The model is 10,000 to 3 times bigger, which is 333 times larger. Here's one for you to do on your own. A train is 6 inches in length, and the actual length is 112 feet. Remember, first convert them to the same units and put them in a ratio, then simplify as much as you can. Pause the video and try this one on your own. So here we go. First I need to convert 112 feet to inches. So I have 12 inches per foot times 112 feet equals 1,344 inches. And now I need to put it in a ratio, model to actual, so I have 6 to 1,344, which is simplified to 1 to 224. So I have 6 inches to 112 feet, which is what we started with. Or 3 inches to 56 feet. I find these ratios much easier to use, but this idea of a scale factor is still very important, because that's how it is usually communicated. So now we're going to use scale factors, and we're going to use scale factors in 2 ways. The first way is from a map, so we're going from a model to the actual length. So what we're going to do is we're going to do the actual distance to the given distance, so we're going to actually flip our scale ratio, our scale factor, upside down. I like to do this because then these two measurements from the map cancel out and we're just left with the actual units. This takes out some of the worry about units being correct or incorrect. So remember, if you're going from a map to an actual distance, you take the scale factor and flip it upside down, so you have actual to given, and then multiply it times the given distance on the map. So let's do this with our map of Wisconsin. In that case, we had 2 inches equaled 40 miles. And we want to know how far, in actuality, is 4 inches on the map. Well, first, I take this actual to given, so I have 40 miles to 2 inches, which is the same thing as 20 miles per inch. All I did here was simplify this ratio to something easier to work with. So now I'm going to set up my 20 miles per inch and multiply it by the 4 inches on the map. Now if you remember all the way back to unit analysis, these 2 inches will cancel out, and in the end we're just left with 80 miles. The second way to use scale factor is when you are actually making a model, which you will all do when we make our scale models in class. And in this case, I like to use the ratio as it is given, the given to actual, times the actual length, and then we'll find what we need to find. So, say we have something that is 1 foot. Say we have something that is 5 feet. Some of you did this in class with that activity, and you need it to be 1 foot. So we are shrinking something that is 5 feet to something that is 1 foot. So say we were 5 feet tall and we want to know what would happen if everything shrunk so that we were 1 foot tall. So I have a desk that is 2.5 feet tall, and I need to see what it would be like if it stayed proportionate to me and I shrunk to 1 foot. Well, I'm going to take this ratio of the given to the actual, so here's my model to the actual, and then I'm going to multiply it by the actual length. So I have 1/5 equals 0.2. This gives me a number just to stick into this big thing here. So I have 1 foot to 5 feet times 2.5 feet. Remember, this is my given to actual times the actual. Now if I wanted, I could just use this ratio and punch 0.2 times 2.5 into my calculator, because I know that 1/5 is just 0.2. And what you get is half a foot. So if something was originally 2.5 feet tall and we shrank it down using this scale, it would end up being just 1/2 foot tall. So, which scale factor should I use? So when you are making your model, you will have to answer this question, and that all depends on what you are making a model of. First of all, it depends upon how big a space you are trying to fit it into. So many of you will be making your models in shoe boxes. If my shoebox is 6 inches tall, then that's the space I need to fit it into. Now we're going to divide that space by the largest measurement. So if my thing that I'm using is 6 inches tall, and the thing I am making a model of is actually 18 feet tall. I need to fit this into that. So what I'm going to do is I'm going to go 6 inches divided by 18, and I get 1/3 inches to feet. 1/3 inches per foot. That's my scale. Now you'll notice this is not in the same units, so I might have to go inches to 3 times 12, which is 36. 1 to 36 would be my actual scale, but I'm probably going to use this because most of my measurements will be in feet. So this is my scale, and now I multiply all my measurements by that number to find how large they are in my model. So if my door is 8 feet tall, which would be reasonable, I multiply 8 feet times 0.33 inches per foot, which is approximately 1/3 inches to feet, and I end up with 2 2/3 inches. Now what this does, using just 1/3 inches to feet, even though it's not simplified the way the ratio is supposed to be, it allows me to skip that extra step of converting my feet to inches, and I get 2 2/3 inches. Alright, and if you want more examples, well, I got my pictures from here, and there are some examples in other spots, like this one was my map, this one was that airplane picture. Alright, well thank you, and I'll see you in class.